Okay, so worksheet 4 is a little introduction to parabolas, and then we're going to kind of review what we did last week. Remember, we solved by square rooting, completing the square, factoring, and quadratic formula. We're going to do all those things again today, but we're going to have some pretend imaginary answers mixed in there. Okay, so nothing horribly new. The basic, or what's called vertex form, not basic, vertex form of a parabola looks like this. I hope this is not new to anybody. Can anybody tell me what A does? Okay, it is a stretch. It's actually a vertical or vertical stretch or shrink. With a parabola, you can't really tell if it's horizontal or vertical because it looks the same. What else does A do, though? Does one other thing. It determines, does it shift it? It determines whether it opens up or down. Does that sound familiar now? Up if it's positive, down if it's negative? Okay. What about this H? That's a shift. It's in with the X, so it shifts which way? Yeah, the X goes this way, right? So it shifts left or right? And this guy, the K, tells us the shift what? Up or down. Now, where's the actual vertex at then? That maximum or minimum point? It is the opposite of this, which we just call H because you're taking the opposite because of that guy. And then K. All right, HK is the vertex, and a vertex we will also refer to as a maximum or minimum point eventually. Okay, please tell me I didn't tell you anything new. That all is familiar. Okay, these are just some pictures of parabolas. What makes them open up? Yep, this one had a positive 1x squared, a positive 1/3 x squared, and a positive 5x squared. And the ones that opened down had a negative 1/10 x squared, negative 1/4 x squared, and a negative 4x squared. Axis of symmetry we didn't really talk about yet. All of the parabolas we're doing today will open either up or down, so the axis of symmetry is a vertical line through the vertex at x equals h. Eventually we will do parabolas that open sideways, and they will have horizontal axis of symmetry at y equals k. Everybody all right? Yeah, we'll go with math. All right, before we do these, what I want to review really quick with you, I would like you to learn to do these without a calculator today. That being said, I am not going to ask you to graph a parabola by taking away your calculator, okay? But what I would like you to be able to think about is this basic parabola. When I go from the origin is 0, 0, right? And that's the vertex of that parabola. Everybody good? When I go out 1 to the left or the right, what happens? Yeah, when I square it, I still get 1, right? Up 1. All right, if I go to the left or the right 2, what happens? When you square it, you get 4. And if I did 3, kind of out of room here. Okay, I want you to keep that in mind because that will determine points for us off of the vertex without using our calculator. So, where is the vertex on number 2? It says in the directions, accurately sketch, state the vertex, and show at least 2 other points. And you don't have to write ordered pairs for the other 2, they just need to be accurate. So we had 2, 1, everybody okay? We took the opposite in the parenthesis and not this guy, so we go 2, 1, put the dot. All right, that's the vertex. Now, the vertex isn't at 0, 0 anymore, but this will still help us determine, because the A value is still 1, there's no stretch. So when we go out 1 either way, we should go up 1. When we go out 2, we should go up what? 4, because you're squaring it. Okay, so over 1, up 1 on either side of that axis of symmetry. What's the equation of the axis of symmetry? It doesn't ask us for that, but it would be x equals 2. So we go over 1, up 1 on either side. But back to the vertex, if we go out 2, we go up what? 2, 4, because, but you got to go back to the vertex to do that. All right, does that look like a parabola? Is there a constant rate of change between the red and the blue and the blue and the green? No, it's not a slope, right? It's not a constant slope. It makes a curve that's called a parabola. And it shouldn't be a V. It should be like a U at the bottom. That wasn't the worst one I ever did. Might need the big dot theorem. Right? Make these dots a little bigger, then it goes through them. All right, who can help me with number 2 or 3 over here? Sorry. Vesma, where's the vertex? And what else can you tell me right away? Sideways? Is that what you said? Okay, so we're going to go out 1 and down 1. She said there's one at -2, -3. Good. So either way. Good job. If we go out 2 from the vertex, we'd go down 4. And why are we going down again? Not because we ran out of graph paper and it seemed appropriate. Because there was a -1A here. Yep. There was no graph paper, so they must want us to go down, right? Yeah, let me give you graph paper that only goes one way on the test. Never know. It might happen. All right, what's going to change on number 4, guys? It has a stretch. All that stretch does is multiply by that squared quantity we just talked about. So the vertex is at +3, 2. Yep, 3 to the right and up 2, right? Almost went the wrong way. Oh, it didn't even hit the dot there. Nice big dot. Okay. And then instead of going out 1, down 1, I'm supposed to multiply that by 2. So I go out 1, down 2. And instead of going over 2 and down 4, I'm going to multiply that by 2, and it's going to be 8. From the vertex again. Out 2 and down 8 puts me at -6, I think. 1, -6, sound right? Mm-hmm. And 5, -6. Okay. I really struggle the longer and skinnier they get to make them look like a U and not a V. I could just totally make really big dots there.
Make like a smart notebook just for math teachers, you know, like insert the parabola.
Yeah, even in Word, parabolas are really hard to do. Did I ever show you guys Desmos calculator? Anybody used that one before? Desmos is really nice, but because you don't have to get things in y = form. This one is already in y = form. but you just type exactly. You put in the equals and everything. So what was this one? Y equals -2.
X minus 3.
Oops. Okay, and it gives you little ordered pairs and everything over here. The reason math teachers like this one is because later we're going to do things like this with x's and y's squared and get things like ellipses and hyperbolas.
So weird.
And this calculator will do that. Your calculator is not happy with that equation at all because you can't get the y by itself easily. All right? So, fun to look forward to. No, they're not hard. They're not hard, I promise. Okay, what's going on over here? So, out 1, up. Yep, it has a 3 out here, so we're going to out 1, up 3. 1, 2, 3. And if we go out 2, we'd normally square it and get 4, and then we're going to multiply by 3, which is 12. So from the vertex, I think it's all the way up here at 8, isn't it? Now, am I going to take your calculator away from you? No. So do you know how to do that on your calculator? And find nice, pretty ordered pairs by going to the table? If you go to y equals, and you make sure the plots are off up here. This isn't very big. Need me to make it bigger? Can I just do that? No, just kidding. I thought that was a zoom, not a search. Yeah, see? No. Just ignore Hofbauer. Yep, I broke it. All right, y equals, you want to make sure these plots across the top are all off. Do I have this one typed in? No, almost. 3 parenthesis x minus 2 squared minus 4. And then a zoom 6 is always nice to get a standard window. This one's going to be in the standard window, I think. What just happened? Oh, there we go. But how do I find out ordered pairs? Second graph will get you the table. Oh, thanks. That's going to bother me that those are, I think I had trouble with that earlier. And if you do second window to set your table up, it really doesn't matter as long as you have a whole number for your starting value and you count it by ones, you'll be good. We're going to eventually use this Ask Auto feature, but for now you just want it on Auto, and you're changing table by ones. Doesn't matter what your starting value is, as long as you tell it to go up by ones, because you can scroll. Okay, can scroll up and down and find numbers that fit on my graph paper, right? Okay. Everybody connected those dots and made it look pretty, right? What's going to happen on these two? What is this 1/2 going to do? Can you predict that? It is going to multiply by 1/2. It's going to get wider. That's really not what it does, but that's what we all say. It actually compresses it down. Okay? It actually compresses it down. It does look wider. Vertex, -4, 4, going down. Instead of going out 1, down 1, it goes out 1, down 1/2. Nice half graph paper for us, though, right?
For you.
Oh, you guys can't see the lines on yours? Or... Okay. Out 2 would normally down 4, but we're supposed to take half of that. What's half of 4? Oh, I can manage to draw this one pretty nicely smooth, I think, because it's wider. So somebody want to come up and do number 7? Go ahead and do number 7 for us. You guys see if you can get it done before Miranda does. Yeah, you come up and do it on the board. Yeah, just use the pens. It's easier than the tablet. Not calibrated very well. Really big dot. Sorry.
Hold on, that's okay. It's not your fault. I was pretty proud of that.
You're good. Yeah, I'm proud of you. Careful. Over 1 is all the way to the next dark line.
Oh, dark line. Right.
Yeah, they're. I don't like when they do this. Do you see the scale is different on the X than it is on the Y? And it's not. Yeah, this is not her fault. It's not calibrated, guys. She's trying. Here and here. And then. Yeah. She's trying to draw it way above so that it.
Okay. That one was alright. Right.
Yeah.
Different color.
All right, I need to calibrate the board. Is everybody okay though with those
You can see my
pretend
dot,
points? Good job, Miranda. Nice attempt. All right, everybody okay with the parabolas?
Yours are better than mine.
All right, yours would have been much better if you had the board calibrated. Okay, on the back of the worksheet, all we're doing is reviewing all the things we did last week. We just want to be efficient and use a method that seems appropriate. And we want to remember some of these are going to have imaginary solutions. Okay. We'll do 8 together, and then you guys can do 9, because 9 is way easier than 8. What do we have to do first, though, on 8? Use our Algebra 1 skills. And some more Algebra 1. Somebody's going to want a square root right here. Okay? That's not a good plan, okay? Divide by the 10 first. Don't forget, because, oh, I'm skipping steps left and right. N squared equals, okay. This doesn't reduce, though. It does reduce by 2 to negative 38/5, yes? Okay. Now what? Okay, and because we're square rooting the n, we get absolute value, or we just remember plus or minus. What are we going to do with that top? Yeah, we're going to poke out an eye. So we have I square roots of 38 over square root of 5. Anybody want to cry a little bit?
I wanted to cry
We
before I got it.
still got to multiply by square root of 5 over square root of 5. Because of that weenie mathematician who decided we had to do that at some point. I think it's 190, isn't it?
Probably. You're usually right.
Square root of 5 times square root of 5 is 5. Now, square root of 190 kind of seemed to me like it should simplify.
It doesn't.
But it's just 19 times 10 if you break it down, and none of those are perfect squares, right? There's a 2. I mean, there's other factors because this breaks down to a 2 and a 5, but nothing's squared or perfect square. It's just a hot mess. Okay, can you guys work on number 4? See what you get? This one's easier, I promise. There's no denominator. What'd you get for 9?
Plus or minus I.
Okay. Is it okay to write this? No. This is a complex number that has both a real and imaginary part. This is a complex number that has no real part, otherwise known as a pure imaginary number, right? Disgusting one with a square root, but it doesn't have a real part. Okay, so this is not working. Any other questions on that one? Okay, that takes us to completing the square. Some of us wouldn't choose to do this by that method, but it's a good review of that. What do we do first? Jared, did you need me to go back?
No.
Okay. Yeah. I do a lot of things. Okay. What do we do first? After we move the negative 91 or the 91 to the other side and added blanks, we divide this by 2 or take half. X plus 5. And to get the blank, we square this guy. I don't know, 66 negative? Everybody okay? Omar, did you leave a half sheet in here about U.S. history? When you came in on Friday and grabbed your book, I found this half sheet laying there and I was like, oh, this is probably your homework for the weekend and you didn't have it with you.
Right.
Sorry, didn't mean to tell a funny. Okay. It's up on the table up here. I'll get it for a second. This side is just going to square root down to x plus 5 plus or minus what's happening over here. What do you think? 6 times 11 is what I see right away. Anything going to be perfect in there? Okay, last step. Subtract 5. So how would you like me to write that? Negative 5? I heard some positive 5s, I thought, but I might have just not heard. I didn't think it was that gross. At least we didn't have to do quadratic formula and divide and reduce. No, it doesn't look nice. If you wrote this in A plus BI form, you might put the I at the end. I just don't like ever putting the I at the end of a square root because it looks like it's going under the square root and it's not, right? Everybody knows what I'm talking about. The I is not underneath the square root. Yeah, absolutely. And you can write the I at the end. Just make sure it doesn't look like it's under the square root. All right, try this one, guys. You can do this one on your own. Anybody want to come up and do it on the board? Come on, Basma. I could calibrate it real quick for you so it actually worked, right?
She has an unfair advantage.
I had my board installed extra high because I'm tall. So. You're done with that one, look at the next one, see if what method you think would be a good choice for that one. It didn't cooperate. Oh, do we have to poke an eye out on this one? What do you think, guys?
Yep.
Is that what you got?
Yep.
Did anybody simplify?
I didn't have my calculator, so I didn't check.
Now, can we reduce that? No, because there's no divisor we can take out or anything.
I mean, we could put one, but it won't be the same number.
You're right.
We could reduce if we really, really want it. We could get that answer.
If we wrote x over 2 equals, then we could. All right. Everybody good? What'd you do first on 12? Anybody who's gotten there?
Well, I
Yeah.
tried to factor it, like,
You
in
can-
total.
Somebody's going to do this.
That's a smart idea.
And that's all good. But does this mean 2 equals 0 is one of the solutions? No. Because 2 doesn't ever equal 0. Okay. So that constant can actually just be divided off when you have an equals. And if you divide this by 2 over here, you still just have 0, right? Okay. Does that factor? Factors that 4 that make 1? No. So what's our next choice? Yeah, quadratic formula. I don't think you want to do completing the square just because you would have a 1/2 in here then, right? You could do that, but yes, but you're not going to get to use the program on Wednesday when you take the quiz, so it's great practice. A equals the opposite of what? Whatever the b here, which is 1, plus or minus the square root of 1 squared. 4 times 1 times 4, right? Did I do that wrong? 4ac? All over 2 times 1 or 2. I didn't get 28 though. I got, what, negative 15? You good, Bestman? Did you figure out what we did? Does that simplify it all, guys? The only thing you have to do is what? Take out an I. Sounds painful. Did I do it wrong? Or are we good? Was that one that easy? Okay. Work on 13. Anybody want to do it on the board? Is it negative 164? Is that right? Well, I'm thinking 4 goes into 164, yes?
Mm-hmm.
So this is a square root of -1, which is an I, a square root of 4, which is 2, and a square root of 41. Did I divide that right? You do not have to separate it, but you have to reduce it correctly. How does it reduce, guys? 2/9. Back here, what do we get? Yep, you have to divide that 2 into the 18, so you get this. Or -2 plus or minus I square roots of 41 over 9. See, what my concern is here is that you reduce only this piece, and you leave this 2I square roots of 41 over 9. It has to be I square roots of 41 over 9, because you've divided the 2 out of both pieces. That says 41, doesn't look like it, but is that better? I don't know. Just looks like a big blob now.
I would like a big blob.
Is that it, or is there a couple more? Okay. Anybody see a shortcut on 14? What'd you say? Cross it off, skip it?
Yeah.
Come on, somebody knows. Okay, 6 times 2 is 12, so we want that to be negative, and now 1 to be positive, so that we get a -11 in the middle. I always try factoring first, because I'd rather factor than do quadratic, but that's totally up to you. What does that make V? All right, what about 15? Divide everything by 2, that will help. I'm going to make it equal to 0 at the same time. Okay, was that skipping too many steps? When you moved them over to the other side, you had to subtract and add, right? I don't think it's factorable. Did I lose anybody on the rearranging there? No. Some of you want to move it the other direction to the right side and maybe say 0 equals -3x squared plus 10x minus 10. I hate when a is negative. That really bothers me for some reason, especially if I'm trying to factor. Okay, so I would have moved it this way. All right, I think we got to do quadratic. See what you get. I don't know, I might have done something wrong.
No, that's what I got, so let's be
Well, I kind of like that the square root didn't have to simplify anyway.
I literally, okay, you know, I put a line and they're all like European 7s. I literally just did that to my 5. I just made up the 5. I went and I put a line through it like that. What is wrong? Don't answer that.
Anybody not getting that need help?
Whoever watches your videos in half hour is like, who is that chick that sits next to half hour?
She talks a lot. All right, guys, what about the last one here? If we subtract 7n We get 0. Now there's no b term, so I'm not going to do quadratic. What am I going to do?
Subtract.
Subtract and divide, so I get -4/11. Ugh. So I get n equals plus or minus. What is the top? The square root of -4 is 2i. But I still have a square root of 11 in the denominator.
Yes. Okay. My second favorite number.
Plus or minus, yes, 2i square roots of 11 over 11. Do I need to write out that step?
At least it was like not a hard multiplying thing. We didn't have to like use the brain.
Yeah, it didn't simplify really, it just... Okay, guys, so your homework, guys, for the homework check, you need to do worksheet 5, and you don't forget we did bookwork on imaginary numbers, on complex numbers on Friday. That's also due. Those are both due on Thursday.
Wait, okay, so this isn't on here, so oh, it is worksheet.
Those are both due on Thursday, okay? There is a quiz on Wednesday. It's all this, it just has, you know, solve by square rooting, solve by factoring, solve by, I don't know if it has exponents on it, I'll look. Did I turn this off already? Where did it go?
Down to the bottom.
Oh, there it is. I'm like, where's the little...